Every day we see incredible, inspiring examples of what AI can do for us. It's a topic on everyone's mind, but we should never forget that those advancements, what we celebrate, it's a really bad weapon in the bad actors' hands. AI is becoming most of the powerful weapons we've never had. So my name is Dmitry, and today we're going to explore the darker side of this technology. A new kind of threat called the AI impersonator. Let's discuss how our response must evolve from just simple code security to intelligent runtime defense. For years, we were given the same advice to our friends, family, and users. Look for the typo. It was a classic sign of scam, a telltale crack in the facade that revealed a fraudster. But in the age of generative AI, those cracks are perfectly sealed over. This advice isn't just outdated, it creates a false sense of safety. The game has fundamentally changed. If the attack looks perfect, your app needs a sixth sense. Who is this new adversary? It's what I call the AI impersonator. It's not a single tool or just a one person. Think of it more like a suite of AI technologies working together. You've got a generative text that's perfect. A scary convincing voice synthesis that can replicate your voice just from the few seconds of audio, and even video generation for deepfakes. It's a toolkit designed for one person to build a completely believable digital deception. It doesn't hack code, it hacks belief. And why is this hitting us now? It's because we're in the middle of a perfect storm created by the three converging trends. First, the democratization of AI. The advanced models that were like the state of art a few years ago are now cheap, accessible, and easy for everyone, including the bad actors, to use. Second, a huge amount of personal data. Years of using social media have made a massive public record of our lives, which is great for training attacks, specific to each person. With OSINT plus LLM summarizers, the public traces can be mined and can be turned into tailored pretexts. And the third one is a mobile. Mobile is currently epicenter of trust. Our phone holds identity, money, approvals, and making it the highest value moment to attack. Let's make this risk feel real. Meet Liz. Liz is a freelance developer right here in Prague. And she uses a fintech app called Talsec Bank to manage her international payments. The attack on her begins not with a code, but with a context, a super personalized. Attackers used the AI scrapper, and they found out that she recently attended a conference in Tallinn, Estonia. Then they craft a hyper-personalized SMS that feels urgent and inevitable rather than being suspicious. The sound is loading, just a second.
SMS, CONF Bank Security. We've detected an unusual login attempt from Tallinn, Estonia. If this was not you, secure your account immediately at URL.
Liz, naturally concerned. She clicks the link. The website looks identical. It shows her partial details, name, and the last two numbers of her phone number. She confirms. On the other end, the attacker is using the legitimate system, the real system of the CONF Bank, as sends out and triggers like the login attempt as sends out OTP to her phone. Yeah, but the masterstroke is what happens next. Her phone rings, the voice is calm, confident, professional, and fully synthetic. It's an AI impersonator. It's not just a robot. It's a master of social engineering.
Hello, Lise. This is Martin from the CONF Bank security team. I'm calling about the security alert regarding a login from Tallinn, Estonia. I can see you've just initiated the verification process. We need to act quickly to terminate that unauthorized session. The security code we just sent to your phone is the final key to lock them out. Please read that code back to me so I can complete the security lockdown on our end.
And she reads back the legitimate OTP code, and just like that, the breach is complete. By successfully deceiving Liz into handing over her legitimate OTP code, the attacker got an access to her app. Everything tactical worked as designed. The app itself was secure, the encryption was unbroken, the human was the target, and the human was the entry point. The second attack vector is even more insidious because it happens silently on the user's device. The goal isn't just to fake a message, it's to hijack the critical moment of truth in your app. Think of it as a digital ghost that can haunt the user's device. This is where AI gives the attacker superpower, the ability to replicate your app's UI perfectly and on the fly. On Android, this is a classic sticker on the screen attack, where a shady utility app uses drawer or accessibility permissions. On iOS, it's a door redirect attack, because iOS is more restrictive. The key here is start thinking in motions, not thinking in screens. This new adversary puts us, the defenders, in a difficult position and creating a really dilemma. It's a struggle between sticking with something we already know, even if failing, versus adapting a fundamentally new and more dynamic strategy. On one hand, we have the old playbook. Signature-based detection fails against no malware. Static MFA is efficient, as we've seen with the Liz example. And security training can't prepare users for perfect AI fakes. The only viable path forward is the new playbook. And if we can no longer expect our users to spot these perfect fakes, we need to give our application a sixth sense. We need to build a digital detective right inside our app. This detective's job is simple, and it follows 3 steps any good detective does. First, it gathers clues. Second, it connects the dots. And the third, it takes a decisive action to stop it. So what are these clues? Our digital detective collects 2 types of them. The first ones are behavioral clues. This is a how. Detective analyzes the user unique rhythm over time. Their swiping velocity, their typing cadence, just to understand how do they feel. Are they calm and confident, or they're hectic and under duress? This is on-device biometrics. It does it without collecting any PII data, and any data is leaving the device, keeping it privacy first by design. The second type of clues are contextual clues. This is what and where. Detective checks the scene of the crime. Is device is rooted or jailbroken? Is there any overlay detected? Has SIMs been recently swapped? Are there any geolocation anomalies? This is a foundational signals from runtime analysis, providing the crucial context. But this list of clues is just a noise. The magic happens when a detective connects the dots. Let's see the next example. The request comes in, the event is a new payee added. Our detective started to connect the dots and gathering the clues. So the clues are the following. The event, the new payee added. The behavioral trust is low, is 0.31. It may mean a frantic behavior. The context is a new device, plus a geolocation mismatch. Individually, none of them are crime, but together, the detective's brain, our policy engine, evaluates this against its rulebook. The policy says if it's an event of a new payee and the trust score is low or it's a new device, then trigger a biometric step up. And here is a crucial takeaway. The action isn't just a blunt block, it's a precise, user-friendly intervention. This all brings us to the following mandate. To build your own digital detective, first of all, you need to integrate a specialized SDK that can gather these clues. Second, you must design your policies to be intelligent, not just restrictive. We all had the situations when you change your personal details and then you can't add the new PE because you get a frustrating 24-hour cooling off block, right? Why everyone is treated as a fraudster if it's a legitimate user? With a good policy engine, you can just check for the clues, check your rulebook, and maybe just to trigger a Face ID check. So you only can apply this 24 hours block when detective clues, like a new device or fracking behavior, point to the high-risk situation. And third, you must preempt user confusion by using the clear, context-aware microcopy. I know we've covered a lot, but there is something you can start doing tomorrow. For developers, conduct a critical user journey code review. Find one high-risk moment, for example, a new PE confirmation. Add a simple check from your existing ones, for example, a new device check, and force a Face ID prompt. Use your existing tools, use them more intelligently. For product design, audit your security microcopy, make it context-aware. For example, same example with lease, OTP screen. If you know the context, we can show a hint saying that the Celje bank will never ask OTP while you're having an active call. And for everyone else, run a 30-minute AI impersonator threat model. As an example, you can put your login screen on the wall and ask your team how would an AI impersonator trick our user and what actions we should take. It's clear that AI impersonators present danger, but by embracing on-device runtime defense, we can protect our users and build a more secure future. AI will keep perfecting the look of trust. Our jobs here is to perfect the feel of trust on a device in real time. Instrument the moments that matter. Let's close shape policy. Build your digital detective today. Thank you.
Thank you very much, Dmitry.
Questions?
Any questions from the audience? I guess it's not. That was great.
you.
Thank you so much.